This week we have parent-teacher conferences on Thursday. You're like, didn't we just have those? Yes, we just had those, and we're going to have them again. So we just had them like 2.5 weeks ago, maybe 3 weeks ago, and we're about to do it again. So that is Thursday night. We have parent-teacher conferences, and it's an A-day this Friday. Then Monday, Tuesday, fall break. Whoop, whoop, whoop. Yeah, no classes next Monday and Tuesday. So we shift, and we will have classes Wednesday and Thursday next week. But that's it. Wednesday, Thursday, and then Friday is just the asynchronous day next week. So a very short week next week. So it'll be nice to get a 4-day weekend. So got to figure out what I'm going to do with myself for 4-day weekend. My wife's going to be gone for half of it. There's a family funeral her and her cousin are going to go to over in Oklahoma City. So she'll be gone. They're going to leave Friday and come back Sunday. So I don't know. I have to figure out what's in the theaters. Maybe I'll go see a movie by myself. I haven't ever done that. That'd be interesting. Yeah, well, we'll see. Let's see what next week looks like. All right, we better get to our programming because we got to get out here before cybersecurity can come in. All right, foundations of programming this week. Let's go to our grade screen. Okay, so this week we have a lesson on getting numeric input, and then we got a special assignment. So that's what we have this week, special assignment. And this is actually a program, but it's kind of like a baby program. It's not a huge program. I'm actually not going to require pseudocode this time. This will be the last program that we do not have pseudocode required. Everyone for the rest of the year will have pseudocode required on the template. But we'll take a look at this. But getting numeric input, let's look at that first, because we looked at processing numbers last week. So there will be a little 5-question quiz that goes with this as well. What's in a name? That's what Willie Shakespeare said once, right? He said, what's in a name? The literal answer is letters strung together. That's literally what's in a name. Just a bunch of letters strung together. Great question, Will. But there's lots of other equally significant questions that I like how many Oreos are left over, or what's my age in dog years? A lot. Guess what? You can write a Python program to calculate and answer all those burning questions. The key is you got to know which data type to use. So we're going to learn to distinguish between integers, floating point numbers, and string values. Last week, we looked at integers and float. We're going to understand how computers store different data types in memory. We're going to look at the int and float functions, and int, float, and input functions to troubleshoot and solve math problems. So let's go to page 2 here. As you know, there's a difference between these 3 data types: string, float, integers. See for yourself. So here's a little look at all of that. With string, that's a value composed of letters or numbers that you're not performing a math function with, right? Like hello world, that first thing we did a couple of months ago, right? Hello world, that's a string value. 800-374-1430, that's a phone number. We don't ever do any math with the phone number. So that number would actually just be a string value. Like it's just like having letters, because you're not going to do any math with it. Please enter your first name. That's string. Your address is string. There's numbers in your address, but again, we don't do any math with it. So that's a string value, not a numerical value. So the memory space depends, right? Just depends on how long your string is. The longer the string, the more memory it takes up, because the more letters, the more it's got to save. So let's compare that to floating point. That's a numeric value, either positive or negative, that contains a decimal point, like the price of fuel. Fuel prices are floating point numbers. All of these examples below are floating point numbers: 0.01, negative 1.3, 0.0. The value of pi is definitely a floating point number. It takes a lot of memory space because they have decimals. So the more precise you want your answer to be, that means the more memory it's going to take, right? Because it stores the number and the decimals to a certain point. And the last thing we're comparing between string and floating point is integers. That's a whole number. It's a numeric value that's either positive or negative, like -2, 88, 0, the number of cookies you just ate, because we know you didn't eat half a cookie and throw the other half away. It's an integer. That's the low memory space because it's just integers. It just takes up enough room for just maybe a couple of characters, unless it's a bigger number, but still, it's a lot smaller than floating point. So when writing programs, programmers should keep in mind what types of data they're using. So if you're looking at a value, is that value a floating point? Is it an integer? Or is it a string that you're not going to do any math with? So luckily for everybody, here's an easy way to find out. Follow this flow chart. Will I do math with this value? No, then it's a string. Again, like a phone number. Not going to do math with a phone number. So even though it's a number, it's a string. But yes, maybe I'm going to do math. Does it contain a decimal point? Yes, it does. It's a float. No, it doesn't. It's an integer. It's real easy. Don't make this complicated. It's real easy to categorize what your value is. Lots of values seem like numbers, but they aren't floating points or integers, like your phone number, your driver's license number. Lots of things that we use numbers with, but they're really string values because we don't do any math. All right, test our understanding. All right, here's a whole bunch of things that we have to categorize as either integers, float, or string values. Okay, so 8. 8 should be relatively simple, right? Is 8 a string, a float, or, well, it's an integer. It doesn't have a decimal. 8's obviously going to be something we're going to do some kind of calculation with probably. P. Sherman 42 Wallaby Way. Finding Dory, that's the address, right? Definitely not an integer. It has a 42 in it, but it also has P. Sherman Wallaby Way in it. So it's not a decimal. That's a string value. The points that our basketball team scores. Well, hopefully that's not a decimal. That'd be weird if we scored 33.8 points last night. It's like, what? No, that's an integer. The points that the team scores is an integer. The number of steps you walk, that's only counted as an integer. We don't count half a step. A half a step is still a step. It's just a short step, right? Total books in the Harry Potter series. Is that a float? Was there like 8.5 books? No, there was complete integer number of books. Social Security number. That's not a decimal. That is an integer, but we don't do any math with the Social Security number. Hello world, obviously a string. The number of liters in a gallon. Oh, think about that. If we have 10 gallons, how many liters is that? Or even 1 gallon, because it's the number of liters in 1 gallon. It's not an integer. It's a floating point number. It's a decimal number, the number of liters in a gallon. The result on a stopwatch. Well, a stopwatch is going to have a partial second, a decimal. It's going to have a floating point number. The cost of an ice cream cone. Well, not a whole lot of places sell ice cream cones for $1, $2, $3. They're usually like $1.79 or $3.49. They usually have a decimal in it. 8.342. That's right there, straight up. Your telephone number. Again, it just uses whole numbers without decimals, but we don't do any math, so it's going to be a string value. All right, simple as that. Let's go to page 3. When to int and when to float. Let's say you got a part-time job, so you're working a few hours every week for $9 an hour. Python can help you figure out your pay. This is where the input function might really be useful. Now, we did the input function with our last program, so we're familiar with that. It says write some code that prompts you to input your hours worked each week, and then Python can calculate your paycheck. But you have to tell the data type to Python. So say I'm using float, I'm using integers, what am I using? By default, Python assumes all values you enter using the input function are strings. It's going to assume you're not calculating anything by default. When you have an input, it assumes you're going to enter your name or something, right? Input, what is your name? Name. It's not an integer. And so Python assumes everything that you use an input statement for is going to be a string. But you can't do math with a string. So we have to tell Python we're going to use an integer or we're going to use a floating value when we use that input. So let's see how that works. Job 1. Ginny worked from noon to 6 on Saturday. Her boss told her to enter 6 hours on her timesheet. So she's using Python to calculate her pay. So here's what she put. Hours equal input, enter hours. Rate equals 9. pay equals hours times rate. If she gets a raise, all she got to do is change her program to her new rate. Print pay. So she entered her hours when she ran the program, but it gave an error. It said it cannot multiply the hours times the rate because the non-integer type, it assumes enter hours is not an integer and that this is a float. So it says it doesn't know what to do with that. So she goes back and says, okay, in my input statement, I want this input to be looked at as an integer, not a string value. Don't assume this is letters. Assume this is a number that I want to use. So she has to put that before the input. So it says, okay, everything in this parentheses, int, everything in this parentheses is going to be a number. And I want to do some calculations. So save this as a number, an integer number. So when she saves the integer 6 and multiplies it by the 9.00, it knows that the calculation is going to be in float, because if I have an integer times a float, it's going to give a float answer. So she made $54.0. All right. Let's see what's next. So now she works from noon till 6:15 on Saturday. So boss said that's 6.25 hours, 6.25. So put 6.25. So she goes back to her program. Sheldon goes back. Oh, Sheldon from Big Bang, right? Sheldon goes back to his program and enters 6.25 hours. Going to get an error. Invalid literal for the integer. Because it said, you told me this is going to be an integer, and then you entered 6.25. 6.25 is not an integer value, so you confused Python, and it gave you an error. And it told you 6.25 was the error. So now you can go back and say, okay, let's just use a float all the time. So maybe it'll be a decimal. Maybe I won't need a decimal. You can still enter just 6, even if you told it's a float, and it'll save it as 6.0, right? So it says there, do that as a float, and now it'll calculate the 56.25 that he earned. Page 4, last page of this here, using integer and float. So now we get a practice. So Jenny and Sheldon use special function to convert their time to integers and floating point values. They're really useful. So select the parts of the code to learn how the integer function. Age, that's where they save it. That's the variable. Equals, that means whatever is after this equal sign is what I want you to store in this variable called age. And we said this is going to be an integer. Treat the following as an integer. And we're going to have an input statement. Input, what year were you born? Okay. Well, that should be an integer. You were not born in 2006.7, right? This is not Star Trek, right? You might have been born in the 7th month or something, but when we talk about what year you were born, it's just an integer. Now, if we said GPA, what's your grade point average, equals, this time we said use this as a float. Use this, assume there's going to be a decimal. What's your GPA? Even if you put 4.0, the 0.0 makes that a float, and it'll save that as a 4.0. All right, let's look at each slide here. Read the code, predict the output. It says test your program with the input of 3. All right, numeric input, define main. So we've got our main function. What are we doing inside our main function? Quite a bit here. All right, we have an input statement, and put that as a comment just to let us know what this is. Num pizzas. So I would assume this is the number of pizzas, right? Num pizzas. Input, how many pizzas do you want to buy? And we've created another variable called pizza cost. So each pizza costs $15.50. So all we have to do is ask $15.50, how many you want? Now this says this is a comment. Again, Python ignores this line because of the hashtag. Calculate total. So total cost equals whatever a pizza costs, which in this case is $15.50, times num pizzas. All we have to do is put that little asterisk. That means times in Python. Pizza cost times the number of pizzas. Print the results. You bought, and here's where we entered how many pizzas they ordered. And remember, since this is a number, oh, we have to tell it to treat it like a string. If we're going to print it with strings, we've got to treat it like strings. Each pizza costs, and then there we put the $15.50, and your total is total cost. Now, what happens when we use 3? How many pizzas you would buy? 3. Error, cannot multiply sequence by a non-integer by float on line 9. So when I went to calculate the total cost, it said, wait a minute, I got an error. It can't use a non-integer type. See, the problem was we intend this to be a number, but we didn't tell Python. Python still assumes this is like enter your name or some other word. So we have to go back and say, this is an integer, the number of pizzas they're going to buy. I have to put that in quotes, everything inside the quotes. Treat this like a number, Python. Don't just assume these are words. These are numbers. So now let's run it and say I want 3 pizzas. There you go. You bought 3 pizzas. Each pizza is $15.50. So your total is $46.50. So even though they just entered a number, Python does not know it's a number unless you tell it. So we told it, yes, this is a number. So treat it like a number. Don't treat it like letters. Don't treat it like a string. Treat it like an integer. So then it didn't have any problems. Let's look at our second slide. All right, let's try to move this. Read the code, try to predict the output. Input, num pizzas, integer. Okay, this is just like we just had. Integer, input, how many pizzas you want to buy. Pizza cost. So now we're going to enter what is the cost of the pizza, because maybe it depends on what kind of pizza we're getting or what size pizza we're getting or whatever. Could have a different cost. And then still it just calculates pizza cost times number of pizzas and the same print out statements we just had. So this time we're going to do 5 for the number of pizzas. And we're going to get the really nice pizzas, $19.99. So we're getting like supreme pizzas here. How many pizzas? I want 5 pizzas. And the cost of the pizza is $19.99 each. There it is. You bought 5 pizzas and $19.99. And whoa, what happened to the cost? 19.9919.9919 times 0.9919.9919.99. Something looks really weird. And that last period is just the period we printed. So that's not part of the number. What happened? Well, this is an interesting situation because what it did is the cost of the pizza, $19.99, we did not tell it that's a number. We didn't tell it a number, so it thinks it's just like we typed our name or something. It thinks 19.99 is like just letters, not numbers. So when we said total cost is 5 times the $19.99, it printed $19.99 5 times. See, there's $19.99, and then another $19.99, and then another $19.99, another 9. There's 5 $19.99s there. That's what it did, because it didn't know what to do otherwise. It's like, I know I have an integer. So like if we just input our name, let's do that. How many pizzas will I buy? 5. What's the cost of pizza? Let's put Bob. Your total is Bob, 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 Bob. See, it's just printing whatever we put in there 5 times because that's what it thinks it is. It thinks it's letters. It doesn't realize that that's numbers. So to fix that, we got to go back and say, oh, we need to tell this that this is numbers. And see, we got to use that float function. This is going to be a decimal number, float, parentheses, close the parentheses. Now, if we say we went 5 pizzas and they're $19.99, it's going to multiply $19.99 times 5. But when we didn't tell it, We didn't tell it was going to be a number. It said, okay, I can just print that 5 times then. Bob, 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 Bob. Okay, so see how this works? Python is going to assume every input is a string value automatically every time, unless we tell it otherwise. So we had to use integer, we had to use float. And of course, it gave us a number as a float, because when you multiply an integer times a float, it's going to default to float. All right, third example here. Input, integer, how many pizzas you want to buy? Float, input, what's the cost of the pizza? Total cost, pizza cost times number of pizzas. Print, you bought this number of pizzas, each of them cost this. Coupon, wait a minute, the coupon is this much, your total is whatever. So let's see, what are we supposed to do? Let's try adding a $5.50 off coupon to your order. So we need to add some code to the program that asks the user for the value of the coupon and calculate the new cost. Okay, so we need another input statement. This is the input section. So they put all the inputs together. So we need coupon. Here we'll just put coupon as a variable. And let's see, it's $5.50. So that's going to have to be a float value. Input, how much is your coupon? Quote, parentheses. You can put a space in there just to make that look nicer. Python doesn't care. We can put those parentheses right together or at the space in between them. They're just doing that so we can make sure we count for how many closing parentheses we want. Okay, so now we got the coupon. See, that was the variable they want us to use, the coupon. So let's run it first just to make sure that didn't create an error. We want to buy, how many do they want us to buy this time? Oh, I can't do that one. Let's do the 5 and the $19.99. And the coupon is $5.50. Okay, so that worked. Oh, they want 3 and $8.99. Okay, we'll change it. But 5 pizzas, $19.99. Total coupon is 5.5. But look, the total is still $99.95 because we never subtracted the price of the coupon. So we need to correct our total cost to be total number of pizzas times the cost minus the coupon. And we want that outside the parentheses because the first it needs to calculate the total cost, right? And then here, we'll even do this on another line. So let's do this. So total cost will equal whatever you calculated above. All right. So whatever the pizzas cost, but now subtract the coupon from it. So first we'll calculate the number of pizzas and times the cost, pizza cost times number of pizzas. And then whatever that calculates to be, we'll take that same total and just subtract what the coupon is worth. All right. So they want 3 pizzas, $8.99. These must be like Eureka Pizzas, which Eureka Pizza just went out of business, by the way. They closed all their stores last week. We want 3 pizzas, and they cost $8.99 each. And my coupon is $5.50. 3 pizzas, $8.99, $5.50. So it's only $21.47 because it calculated 3 times $8.99, which was $26.47. I mean, it's $26.97, and then subtracted $5.50 off of it. So, important thing is, anytime you're going to have someone input a number, tell Python it's a number. And in fact, tell Python what kind of number. Okay, this is very useful for your special assignment this week. And let's look at the last page. It says complete the reading, practice. Go to that page 4 and practice. And then let's look at the 5-question quiz before we look at our special assignment. All right. When asking the user for input of a numeric value without a decimal, which function to use? Which is used to convert a string so you can print it. Read this code. There's an error somewhere. What did they leave out? Let's see. Read the following code. Used to prompt users to enter telephone numbers. Which function do you need to use? Let's see. Because floating points have decimals, they're more precise. Is this true or false? All right, so there's our 5-question quiz. Now let's look at our special assignment. Special assignment. See Google Classroom for the special assignment. Use the provided template. All right, so let's pull up Google Classroom right here. Let's go to this week. Do this weekend buzz with template. Click on the template. It will make you a copy of the template. And here's what the template says. This is just a 50 point. This is half the points of a usual program. This is our first time to use integers. So write a program that prompts the user to enter. The user enters 2 integers and display their sum on the screen. If the user is going to, that means you need input statements. So use Python idle, type a heading that has your name, date, short description, 2 input statements. And you're asking the user to enter 2 integers. So 1 integer each input statement. And then you are going to add them together and display the results to the screen. And then make sure you have your main statement, indentation. Make sure your program's working properly, fixing the errors. Insert your code below. Right here's where your code goes. Do not screenshot. I'm not giving any credit for screenshots. Insert your code below and answer the 4 questions usual. So this should be a pretty short program. Name, date, short description, 2 input statements. Add them together. Print the results to the screen. Questions on the assignment? Pretty straightforward. 2 input statements. We did input statements last program, so we already know how to do that. We just need to tell Python it's a number this time. Because if you just do your normal input statements, it's going to go, I can't add these 2 words together. Or maybe it will add the words together. But it won't add them like numbers. So, okay, guys, that's what you got. And you got extra time to do it, really. It's due Sunday night, but who's looking at it? Because we have fall break Monday and Tuesday. So I'm not going to look at anything until next Wednesday morning. So really, you got till next Tuesday to turn it in. But I still put the due date as Sunday night because Monday and Tuesday, you shouldn't be doing schoolwork unless you're behind. But you should get caught up and enjoy 4 full days. Get all your work done by Friday. Don't wait and write this program over the weekend. Don't mess up your 4-day weekend. Get your schoolwork all done before the weekend and make it a great 4 days. So, all right, guys, that's all I got for you. You can get started on this. You can take that 5-question quiz. You can write your, whatever you want to do. You got some time before your next class. So I'll let you guys get out of here so my cybersecurity class can come in, and we'll catch you later.